In this video, I'm picking up where I left off in the last video. I took and built or populated a new PCB. This time I used a faster 7020. So this is a Zynq-7000 20, and instead of a -1, which is what I had on my first board in all the videos up to this last video, I now have a -3, and this will be the new standard board that I use on videos going forward. So instead of 667 for the processor speed, I'm running 866. And that is what you see up here. So I got this running currently. It has a little 5-volt fan. And in this video, what I thought I would do is just kind of see what do I get for actual power draw on this setup that I have right here from the time I turn it on to some of the tests I might go through for trying to benchmark performance. I thought I would also take a look at how would I kind of understand thermals a little bit better. And so that'll be the second aspect of this video is thermals. So power draw and thermals as the system sits today, which you can take that for what it's worth. I'm not doing anything too crazy with it yet, but maybe let me go through a couple of things. And just show you. The first thing I did is I did change my resolution. So this is my DTSI file, my device tree, and previously I was running this 1280 by 720. I have changed that to be 1920 by 1080, so I'm stepping up to 1080p here. And of course, I then took this and rebuilt my Petalinux image, which is what is inserted in this slot right here. There is a little SD card. I know it's hard to see, but there is an SD card right here. And that kind of blends into the desktop, which is also black. But that is running this updated configuration. This window down here is the actual HDMI output that I'm capturing, and so I'm just bringing that into OBS. I did have to pick up a different capture device. The last one I was using, or had been using up to this point, could not do 1080p 60. And so I picked up a little bit better USB capture device, still a very cheap little capture device, but it's running and capturing this output just fine. So as I'm using that, I've got this main mouse on my Linux workstation, and then I have a mouse on the actual Zynq board, which is this one, if you can see that as I move that around. So two different pointers, which could get confusing at times, but I am going to get out of that user interface on the Zynq here shortly. This connection here is just a USB serial connection to the board, and then down here I am connecting to a Windows machine sitting right next to my Linux machine here. And the reason I'm using that is I'm using some software for my digital multimeter. It's a Siglent STM3045X, so it's a pretty basic digital multimeter, but it does have USB connectivity to my Windows PC, and then I can show this, plus I can log data. And I'll be doing that here so I can try to capture, are there spikes? Where are the spikes in current usage? Maybe something else I'll do, I might just for now at least pull this over here, and I think I'm going to run over to my USB serial connection, and I'm going to change into a folder. In the bin folder, I just have a folder that I included in my image with a bunch of miscellaneous stuff, so I can come in and look at this. But one of the things in here I am going to run is there's a monitor temp. And let me just show you what it does real quick. So if I run monitor temp, it's just going to read out from the Zynq itself, what is its internal core temperature essentially. So there must be a sensor obviously built in to that. And it comes back with a raw value that you can then convert to Celsius and Fahrenheit, which is what I've done here. So right now I'm reading that core temperature, and you can see I'm getting this 37, 38 Celsius. It's fluctuating a little bit. Or if you prefer Fahrenheit, you've got the Fahrenheit equivalent there. Now, if I get out of that, and again, this was monitor temp, I could just show you what that looks like. And so in this, I'm just starting a loop and running it forever. And I'm having it sleep 1 second. So every second it's just going to grab me the temperature, which I figured is plenty sufficient. I could run it faster, but that's good enough for the purpose of this video. And it's then calling another file that I have here, get core temp, which looks like this. So this is where I'm basically going out and I'm using cat with sysbus IIO devices IIO : device 0, and then I can grab the this is an internal temperature 0 raw value. So that should be grabbing the value of that. And you'll see as I get into testing here a little bit, you'll see it change as you would expect it as I put a load on it. Or one of the things I'll do is I'll disconnect the fan so we can see what that looks like. Okay, so with that, then I think I'm just going to have this run this loop, and I'm going to leave that running right here. So right now the system's just simply on. I'm sitting over here in this Wayland Weston user interface, and I can see that my system's pulling roughly 630 milliamps of current. And the temperature, I'll just use Celsius as I talk through this, but it really is in this 38 point something, so sub 39 is what we're at. So I'll switch to another keyboard, just the keyboard that's plugged into my Zynq over here. So I do have a USB. This goes out to a USB port. I have some USB storage, a USB keyboard, USB mouse. That's all plugged in through that port right here. And I'm going to get out of this user interface. Now, being that this is running a higher resolution, the font is a lot smaller, so maybe I'll make this larger. And that's one downside to the higher res is on these videos, it's going to be harder to see when I capture it. But there, I've logged in to this, and I might just maybe pull this down here. I'll have to move this window back and forth a bit as I go through this. What I'm going to do in here, though, and maybe I can just have part of this be on the screen. I'll do something like this. See how far this gets us here. I'm going to change into that same user bin REHSD folder, and again, I'm going to show what do I have here. Now, I did update my image so that by default it shows me the colorful listings, which is I prefer, but you can see any of these that are green really are these scripts. And I've got a bunch of scripts that I've put together, and I'm going to real quickly run through these so you have kind of a feel of what those are. So let me just do just a listing of the scripts, and this is going to be off the screen. Okay, that looks like that fits maybe for now. I'll do a clear. So I do have a script that does a frame per second test at 1080. And so if I go run this 1080 script, basically it fills the full frame buffer device of 1080p with this blue color pattern. And then it tells me how many frames per second. And if you watch the last video, you're going to notice this is about half. Now in the last video I was running 720p, now I'm running 1080p, and my guess was I would see a frame per second get cut in half, and that is what I'm seeing here. So again, when I run this, it just simply fills that frame, repeats that over and over and over, and then tries to give me an estimated how many frames per second, how fast did it go through it. And I showed that script last time, but that's one of the scripts that I have here that I'm going to be using. Let me go back and pull up that listing again. I have the older script that I used in the last video, which was the 720. The 1080 just simply adjusts how much basically I have to fill in on a color sample file, and then how much I have to write to the actual frame buffer. But very similar. Get core temp and monitor temp, I have that running in the other window, so I already covered that. I have a couple scripts that'll play videos. It's just going to use VLC or CVLC. I don't even remember which one I use. Let me just take a look at that. So let's look at play and see if I did VLC or if I did CVLC. So CVLC is what I'm using. They both are going to get the same thing done. But those will play videos. So if I want in this window, I can do this. So I can say play video. Oops. Play video 2, or I'll just do the first one, play video. And that will run VLC, which I have in my image. And then you can see this is rendering out. It's a 720p video, but it's of course rendering out at 1080. And not obviously great performance. A lot of this pixelation that you see here, these bigger blocks, that's in the video itself. But you can see the waves. This is obviously not super fast. Let me get out of that. And if I go and play the other one, the second one, that is a video that really moves fast. And so if this was playing correctly, this would be a pretty smooth, you would see these shapes fly out. But there you can see that was struggling pretty hard here at 1080p. On 720p on an older video, that video played pretty well. But at 1080p, it's too much. So that's what those two videos and those two scripts are doing. And the second one does have audio if I quickly set my volume settings. But I'll come to that later. Going back to, let me pull that listing back up again. I then have the reset sound, which does what it sounds like. It resets my sound card if I ever need to do that. Then I've got a bunch of runs, and I'll come back to the bench loop, but I have a run CPU loop, and that's just going to over and over run the CPU test that I did in the last video. And just to show you, run CPU, it's just this. It's calling sysbench, which again is a utility I added into my image for my Linux. I'm telling it to use 2 threads and really go do a test on the CPU and see what kind of performance I get. And then the run, there's a run mem loop, very similar. So I can come in here and look at that, and that's using sysbench to do a memory run with 2 threads, since this system supports 2 threads. And then I have a run graphics loop, which just does that 1080p frame per second test over and over and over. And then I have a run bench loop, which just basically does all 3 of those in a row. So it does the CPU, then the memory, then the frame buffer, and then repeat that whole thing and just keep doing that until I break out of it. And then those setups are other scripts that I use when I first boot up an image for the very first time. I wanted to configure a bunch of things. And I use those for kind of one-time setups for setup and setup 2. And then the user start does some things just to configure my user. And once I have that logged in, that user logged in. So if I go like this, it just sets some stuff, primarily my audio, sets my audio levels, so that if I come in here and do an ALSA mixer, I can adjust these accordingly. And I'm going to actually turn down my volume a bit. Okay. Let me clear to get the cursor way back up top. So that's some of these. And again, over here to the left, I'm paying attention to the temperature. So maybe what I'll do in here, again, if I look at the SH files and I like it in this view, let's just run the CPU loop. So it's going to start putting a load on here now. And as I'm doing that, what we should see is that this temperature is going to start to work its way up. Maybe while it's doing that, I'll just let it run. I will, from my Linux workstation here, connect into that board through the network. So let's add, let's see, Petalinux is my user. And let's see, that should be it. Okay, so I'll come in here and I'll just run top in here as an example, just so we can see kind of what's running. If I hit the 1 key, I can see both the processors, I can see what's running, what's taken up, and I can see a lot of that processor right now is going into sysbench. And as you would expect, right? So then over here, it's just showing the results of that, and it's going to keep looping through those tests. But I can see my temp has gone up. You know, maybe it's up to 40 now instead of earlier I was in the 37, 38. So the temp is going up a little bit. Now what I could do, let me, instead of running this test here, break out of that, and I'll do a clear. I might go run the one that is the run bench loop. And what that, again, is going to do is do one test for CPU, then the memory test, and then that quick little frame buffer, frame per second test script that I wrote. And just trying to, you know, put I guess a stress on this, or a little bit of a load, and to find out, you know, if this kind of load will cause this temperature. You know, how high can I get that temperature as I'm running this. And we're still in this 40 type of number. And I don't know if it's possible to put a heavier load on this. Maybe what I could do is I could break out of this, and let me just clear and do a listing again. Let's see this play video 2. Let's try this one. So again, play video 2 is going to run that, and I probably could put that into a loop similar to some of these other ones, but maybe for now I'll just run this as it is. It's playing audio. You probably can't hear that. I'm not capturing the audio. If it does pick it up, it's just in my mic, and I've got noise canceling so that typically you're not going to see or hear that anyways. But I'll run that again. You know, again, looking in the background, you know, not seeing that temperature fluctuate a whole lot. Maybe I'll play the other video. It's a little bit longer. And we're running top here. We're checking the temperature over here. We've got this video running here. And I suppose I could make more connections. Let's see. SSH. And maybe here, I'm just going to run this run CPU loop. So I'll just let that loop run here. I think on the actual system itself, I'm just going to do the run graphics loop. So it's just going to crank out that graphics test on the actual HDMI output of the system. This window over here is running the CPU test. And then I suppose we could add a third window that's doing the memory test. Now with all of these running, they're all going to run much slower, of course. Oops, that's on the wrong system. And so I'll do the memory loop on this one. Okay, so processor testing, memory testing, frame buffer testing. And I'm just going to shrink this frame buffer, this one, way down. I think you all get the point of what I'm running in that window. It's just going to kind of keep doing that loop. And then it kicks out of it, shows me the result, and then goes through and does the test for another 10 seconds, breaks out, does it for 10 seconds. So these are the tests that are all running simultaneously, plus this top is running and I'm reading the temperature. So I guess 5 different sessions going on here. And I can see where the performance hit is going to be, which of the users and their ID, what is running that's causing that suspension is pretty much one of the big things. This DD would be the frame buffer test that's running, and then top, that type of thing. So looking at this, we're still in this 40 range, and I can see power-wise at almost 700 milliamps at this point. Now, one thing I'm going to do is I'm going to come over here to my fan power, and I'm going to unplug the power. And so power is off. You can see the fan has stopped here. And what I'm looking for is just to validate. I expect this is going to rise. And I was doing some quick testing with it earlier, and it seemed like it'll rise up to about 50 C. Now, I believe I'd have to go back and look it up again, but the Zynq is good up to 80, 85 on that internal core temp, and something in that range. And I'm not going to get anywhere close to it. At this point, with all of this running, without the fan, to me, that's pretty comparable just to a passive, heat sink that I might put on there. But that fan does make a noticeable difference. And like I said, when I was looking at this earlier, I think I saw it get up to about 50. But we'll see. And I do see that my power, of course, has gone down because that fan has been disconnected. So now I'm only pulling 625 roughly milliamps. And this is going to continue to increase here as we go. Now, while that's doing its thing, I might come over here and just show you what I can do with this. I'm going to stop, and I can come in here and look at the data that's been captured since I started it, and I can show it in a graph, and that's what I'm going to pull up here. I'll just make that full screen. But this shows, that, maybe when I turned it on, there were some spikes, whatever it might have been. Maybe I had it on, off, whatever I was doing at that point. And then most recently, I can look at, this data way over here. And I can see that maybe there's a spike. It looks like all the way up. At some point, there's a spike all the way up to 746 milliamps. So that looks like that's where I'm, max-wise looking at. This is hard to see, so I'll zoom in the best I can. But it looks like the max is, 745.797. So this label here looks like it automatically matches the highest value, which is handy. But what I'm going to do is, okay, let's look at my temp. It's up to 47. I'm going to actually shut the system down. So let me do that. Just going to get into, I'm just going to close all these windows here. Get these connections closed up. And on the system itself, I'm going to break out of that. And then I'll just do a shutdown. Okay, so I'm going to turn power off. So back over here, if I get out of this graph view, oops, this and this. I'm going to turn power off. Okay, I lost my video over here. Power was just turned off. And I am going to go ahead and start this just so we have a shorter window of capture. And let's see, my power supply is off, so it's showing a -5, whatever. I'm going to turn my power on. And then in the background, I can see it going through its boot process. And then I'll see if it syncs up to my video output automatically here, or if I have to real quick reset my capture device. The capture device I have has a pass-through that's also going over to my another monitor that I can look at in addition to what it's capturing and showing on the screen here. But I notice that sometimes what I find is that I need to just real quickly unplug and replug in the external LCD, and yeah, that took care of that right away. Okay, so this is what my system's booted up to, and I will make this, well, let's just make this full screen for a second. You know, I gotta switch to my mouse for that system now. You know, I can come up here and open up, for example, my terminal emulator, and I have not tried this, so let's go see if I can do this. I'm gonna change into user bin REHSD. Again, I can do a listing, but I'm gonna go ahead and do this. I don't know what it's gonna do with the graphics test inside of this. Well, let's just try it. What's the worst that could happen? So it's doing the test on the CPU first, and maybe while it's doing that, I'll come over here and get that temperature logging again, because I don't have my fan running right now, so I want to keep an eye on that so I don't cause any issues. So I'm just looking at this. Looks like it finished up with tests, and now it's going to try to do this frame per second test, which I can't imagine is going to work properly as I'm inside of this other environment. So yeah, so it didn't show anything there. That's probably to be expected. Okay, I want to break out of that and get out of this graphical environment and run that test from out here. And I'll just run the loop that cycles between all of those. Okay, so this is going to do, again, processor followed by memory followed by frame buffer. And I'm going to shrink that down. Nothing too exciting on that window as we go through this. But kind of see if what kind of temperatures we get over here as it is running through that. So right now we're in this 49 range. Now, as I'm doing this, of course, it's running this little system, I guess, pretty hard. Let me see if I can get connected back over here. And I probably didn't hit my password correctly. And just take a look at this. So you can kind of keep an eye on the CPU. So basically, as it's doing that frame buffer test, that looked like it was pretty low CPU. But maybe not. I guess we'll keep an eye on this. And maybe just to make sure we do have pretty good CPU usage, I will go run that CPU test independently. Okay, so the CPU test will keep running in this window here. So we've got that. Here's my top. And I can see temperature-wise, again, this is with the fan unplugged. So it looks like, we're at this 50 number. I don't know if we'll see it go too much higher than that. Maybe we will. I guess as we would let this sit longer and longer, that number probably will climb up. I don't know how high it'll get. Now, while it's doing this, I might just use this little infrared thermometer and check out things like, right now I'm pointing to the DDR chip on the right, you can see, and it's at looks like 32.7 Celsius. The one on the left is 32.4. If I try to catch the edge of the heat sink over here, I'm at 34.8. And I can kind of scan around the board. This will be nice when I get a thermal imaging camera to do some of this, but looking at, I'm just kind of moving around. Nothing's very warm here. 31, 32. This is 33.5 Celsius. And really just trying to see power supply, power rails, all of that. Really nothing here for temperature. Yeah, I'm getting a maybe 36, a little under 36 over here on the heatsink to the Zynq. But really nothing there for temps. And it looks like, this is continuing just to really hover around this 50, give or take a little bit. I'm not seeing it climb much higher than that. So I'm going to plug the fan back in, and I think it'll drop it by about 10 degrees Celsius when it's running. So I'll just let the test keep going and then kind of see what that looks like. And while it's doing that, I'm going to come back here and stop this and take a look at the data and have that graph that out just to see what does this look like, as I kind of did just a from start to finish there. And you can see as I plugged the fan in at the end, it jumped way up. But without the fan, you can see that probably during the startup process, we hit maybe a 650-ish. And then as it's going through these tests, you can see different tests are causing different loads. This is probably when whichever combination is causing this spike like you're seeing here. And then plugging the fan back in brought it back up. But it seemed like earlier we saw about that 750 mark is probably the highest. And so I think I'm setting plenty fine as far as my system power delivery capability. I'd have to go back and double check, but I think each of these can deliver like 6 amps. So I don't think my problem will be in the raw power I can deliver here. Other things probably would fail first, but I don't know. And I don't think I've got, if the total aggregate is under an amp here, and that's spread out across 4 of these, maybe not evenly, but I don't have any concerns whatsoever with power delivery. There was a question that came up if I've gone out and used Xilinx's, they have a power estimation tool. And I had not, and I did pull that up today, and I looked through that a little bit, and some of you are probably well versed in that tool. I've not used it before. Like I said, it seems like it asks for a lot of information. I thought I would go through and make a pass through it and fill it out and see what it would estimate for power usage and try to compare that to what I'm really seeing. But after looking at that workbook, it's basically an Excel workbook with macros. I probably am not going to put much time into that. If I do another project like this, maybe I'll try to use it for upfront planning. But for where I'm at right now, I don't. I think it's going to take a bunch of time, and to have it be accurate is going to take even more time. And I think if I just put in loose numbers or don't do it right, I don't think the output of it's going to be very valid. So I'm not probably going to spend any time on that estimation tool. Let me get back out of here and just start this up again. Let's see, where did we get to temp-wise? Yeah, we're down to about 41 with that fan running. So I'll just pull this down here. Fan running though, seems like that gets my temp back down to this 40-ish range, 40, 41. And I'm continuing, to run whatever tests on this. So this window again is cycling through. It looks like right now it's on whichever one it is, the CPU test. So then it's going to go to memory test next. And I know that's hard to read. Again, a challenge with the higher resolution here. Or maybe it was on just wrapping up the memory test. There's my video test again. But I guess at this point, I'm seeing that power there was at 710, 711 milliamps. But with the fan, it just sits down here at this easy 41, 42. Maybe what I could do is, let me get out of this. I'll maybe do this a little bit better. So I'm gonna get out of that connection, close that window. I'll leave this temperature logging up here, and I'll leave this top sitting down here. But I'm going to go over to the actual board and break out of the test. I am going to run the script, this user script. So when I start, I run this just again to set my audio. And I am going to real quick turn down my playback volume a bit. And I'm going to test my audio real quick, just doing an A play. I've got a little rock wave. You may or may not be able to hear that, but it's just playing a little audio output on my board. I have a line out or a headphone plus a speaker, pair of speakers plugged in. So I'm going to stop that just in case it is causing issues with my mic pickup. But this is just going to a pair of little speakers. And actually, I could just show you, it's just a pair of, so two sets of this is what's plugged into that. So that's what my high-end audio system looks like for this board. But I'm going to come over here now, and I'm going to run FP Doom, and that's one folder back. And I know the font here is small, but that's probably not a big deal. That's what I'm typing here. So FB Doom, if I can type it right. I have to point to a WAD file. And let's run Doom. And Doom will have sound effect support here. And we can just see if, running that, what does that do for, power usage or temperature or anything, if it does anything. And this is where you get to watch my impressive Doom skills. And again, I'm not recording the audio, so if it does happen to pick up any audio, it's just through my mic. But, I am getting all the sound effects audio here as I play this. Just gonna get out of here. And as I'm looking at this over in the temperature, I can see that really not much Not much for any change there. I'm going to get out of Doom. Okay, and I'm out here in the console now again, so I'll just clear the screen. So going through that, fan, keeping it down here at this nice 40, let's just say 40C, or just a little over 100 Fahrenheit. Sitting perfectly good there. Let's just see if there was anything different as I was going through that on the log data. No, so nothing too much. Looks like as I'm running Doom, you can kind of see where this is fluctuating between whatever here, 680 and 690-ish. And so let's just see, where does it sit idle now maybe. Let me just go back and start showing this again. And I think I'm out of everything, so I'm just sitting at a console prompt there. And let me get out of here. Wrong keyboard. Okay, so out of that. And I'll let the temperature monitor keep running. So right now there's really no load on it. It's just sitting idle, and just running this temperature check is all it's doing. And you can see that when it's idle, we're in this 625 milliamp type of window. So it seems like I'm going from 600 to 800, worst case scenario, on this build right here. Now, I don't know, and I haven't paid much attention yet, are there things like if I go do network activity, is that going to generate a lot of power usage, or do something intensive with storage, whatever it might be. But it seems like, I'm doing some network, no big file transfers though, it's just light traffic. This USB-C connection is doing just light serial traffic. This USB here is just doing keyboard and mouse for all practical purposes. I do have some USB storage plugged into that also, but I'm not doing anything. I didn't do any testing with that USB storage to see how it impacts anything. And I do have a powered USB hub hooked up to that, so it's not like it's going to try to draw a lot of power. All those peripherals will pull power from the powered hub. And with the sound playing in Doom, you kind of saw where it was sitting at. Maybe I'll do one real quick last scan. Where am I sitting at for the DDR? So I'm reading 29.7 Celsius and 30.3 Celsius. So this right DDR does seem to get a little bit warmer than the left one. If I go over to the Zynq itself, I'm in this just short of 30 degrees Celsius. So that's probably good enough for now. Maybe a pretty boring topic, or maybe you find it interesting. I find this interesting myself, just kind of seeing what kind of power this pulls and what kind of thermals I'm seeing. I imagine there's something I need to figure out how to do that's much more aggressive on the system than what I'm doing so far that might heat it up more. But as of right now, it seems like thermals are looking good even at 1080p. I will probably change back to 720p for future videos, just because this recording at the higher resolution, it's hard. I either have to do a lot of post editing of zooming in and out, or it's just going to be hard to read. So 720 will be easier. And I'd also say when I get to these other videos and I play those, like if we had, let's change into this, my REHSD folder, clear. And if I do this play video 2, this video runs smoothly at 720, but it does not, it hardly runs here at 1080p. So that's something that I will prefer to see it running better at 720p. The system I have is just really, it's doing 1080 right now, but really it is not going to do it well. 720, maybe you could argue it was marginally doing it decently. again, no graphics acceleration, so this is all just plain old frame buffer stuff. So that is not very helpful when it comes to video performance, but good enough for now. If you've got thoughts, drop them. If there's something you're seeing that you got questions on or suggestions of things I should try out, do let me know. Thanks for watching.